All right, I want to talk a little bit about units with derivatives versus integrals. So let's say that we're working with a derivative, okay? So say we've got a graph that's got meters on one axis and seconds on the other, and you've got a curve doing this kind of thing. Remember that when you find a derivative, and we've been using the term instantaneous rate of change, but the official calculus term is a derivative, you're really finding the slope of a tangent line. And so you're basically saying, all right, if I drew a tangent line to that graph at that point, what would the slope be? Okay, and we've been finding a slope here. A slope is a change in y over a change in x. Okay, or in calculus, sometimes we say f of b minus f of a all over b minus a using function notation. But in the end, your y coordinates would be in meters and your x coordinates would be in seconds. And so you get a number of meters per second, and that ends up being a velocity that you found. Okay, so the rate of change of position over time, or the rate of change as position as time changes, is velocity. Okay, now let's say that I had given you slightly different units here. Let's say that my graph had been a velocity graph to begin with, and then I had meters per second on this axis over here. Okay, so it's a velocity graph, and I'm speeding up and I'm slowing down, and I'm speeding up and slowing down. Okay, well, if you found the slope here, you're finding the rate of change of velocity over time. Is the velocity increasing? Is the velocity decreasing? Okay, which we call acceleration. That unit would be a number of meters per second would be your y coordinate divided by seconds. And so, for example, let's say that the velocity increases by 5 meters per second over the course of a second. We could say that the acceleration is 5 meters per second per second. In other words, every second that goes by, it increases by another 5 meters per second. The velocity increases by that amount. You can also, remember, dividing by a value is the same thing as multiplying by the reciprocal. So you can also say this is meters per second squared is sometimes the value they'll use for that instead. So meters per second or meters per second squared, that would be your rate of change of velocity. That would be an acceleration. All right. So a follow-up here. Let's say that I started you off with a velocity graph, and I want to estimate the area under the curve. Okay, we're finding now what's called a definite integral. Okay, you're finding areas. Okay, so you're gridding this thing off. Okay, and again, I don't know what the units are here, but you're gridding the whole thing off, and you're counting up blocks. Okay, each of those blocks is a 1 meter per second by 1 second wide block. Okay, you find an area by multiplying. When you're working with integrals, you're multiplying an x value by a changing y value. Okay, it doesn't have to be a changing y value. But anyway, the point here is you're multiplying meters per second by seconds. And you can see when you multiply those together, you get a unit of meters. So when I have a velocity graph and I find the area under it, it's going to give me the distance traveled over that time interval. All right, which is maybe a little bit different than what you might have expected. All right, if I had an acceleration graph, the acceleration graph would tell me let's say this graph had been meters per second squared. Okay, you're still multiplying your units. You're multiplying meters per second squared by seconds now. Okay, so if you had an acceleration graph and time, and you multiplied those together, your new units would be meters per second. And that basically would just tell you how much your velocity changed over that time period. Okay. Anyway, the big takeaway here, when you're finding a derivative, when you're finding a rate of change, you're dividing your y coordinate by your x coordinate. When you are finding a definite integral, you are multiplying the x and y coordinates. And so you can multiply your x and y units to find out your final units when you find an integral.